Okay, here comes problem 4. First of all, it gives us a picture, it gives us an equation of f of x, tells us we have a maximum point at m and a point of inflection at n. Okay, maximum and minimums we get from using the first derivative. Points of inflection we get from using the second derivative. So, find the first derivative. Look at that. They're going to basically step us through this problem. Okay, so the first derivative, 3 times 1/3 is 1, so I get x squared. 2 times 2 is 4, so 4x, and minus 5. There's our first derivative. Find the x-coordinate of n. So I said to find a maximum, we use the first derivative, and we set it equal to 0, because at the maximum point, the slope is going to equal to 0, and this is the slope function. So I'm going to set that equal to 0. I'm going to factorize it, and I'm going to have x times x. 5 is going to be a 5 and a 1. I need more positives than negatives, so I'm going to put plus 5 and minus 1. So if I solve this, x plus 5 equals 0. I get x equals negative 5, and x minus 1 equals 0. I get x equals 1. Okay, now we just got to be logical. Look at the graph. Which one is point M? What could that be? Could it be negative 5 or positive 1? Clearly, it's got to be the negative 5. Okay, and x equals 1, that's got to be this one right here. Okay, so the one we're looking for, the coordinate, the x-coordinate of m, is going to be that one at negative 5. Okay, find the x-coordinate of n. So as I mentioned before, to get a point of inflection, we need the second derivative. So to get the second derivative, we take the derivative of the first derivative. So the second derivative is equal to 2x plus 4. And now we set that equal to 0. Because points of inflection happen at the maximum and minimums of the first derivative. Right? So we minus our 4, we get 2x equals negative 4. Divide by 2, we get x equals negative 2. So right here, x is equal to negative 2. And that makes sense if you think about it. If this was negative 5, and this was 1, and that's negative 2, you know, it kind of looks like this is actually pretty much drawn to scale. Doesn't look too bad. Okay, the line L is the tangent to the curve at 3 and 12. So 1, 2, 3, and oh, it's going to be somewhere off where we can see. But that's okay. Find the equation of L in the form y equals ax plus b. So first thing we need to do is find the, we're going to use y equals mx plus b. They wrote ax plus b, but this is my m. This is my slope. So I need to find my slope. Well, I have the gradient function. Here's the gradient function. So I need to find what is the gradient when x is equal to 3. Here's my x. So when x is 3, what is my gradient? So I'm going to do 3 squared plus 4 times 3 minus 5, just using my gradient function. So I get 9 plus 12 minus 5, which is equal to 16. So my slope, my m, is going to be equal to 16. Okay, that gives me my m. m is equal to 16. So I now have y equals 16x plus b, and I have a point that I can now substitute in. So 12 is equal to 16 times 3 plus b. 3 times 16 is 48. Subtract 48 from both sides, I get b is equal to negative 36. So the equation of my line is y equals 16x minus 36. That is the equation of L, which is tangent. Notice it's tangent, it's not normal. Normal, I would have to do the perpendicular, the opposite reciprocal for the perpendicular slope, but this says tangent, so it's just find the slope at that point and use it to find my equation of my line. There it is.